Hello students, hope you all are keeping well. So today I am going to discuss a part on the chapter light in our NCERT syllabus. It is unit 3, the natural phenomena. The topic starts with reflection from curved surfaces. Okay, in the meantime, certainly you watched the video on basic about the light. I mean the different types of rays which are very commonly used for any ray diagrams to study the chapter light. Okay, so just to try to recap, once doing again for you. Hope you observe the video, but let's see once again more. Just it is in the sort of recap. I am going very fast. Okay, so if any problem is there, then in the discussion part I will ask you the questions and I will discuss your any problems. Okay, let's start. The first is a ray of light. A ray. This ray of light is a straight line with arrowhead. Okay, so the arrowhead you especially see arrowhead. The arrowhead is essential to indicate the direction of propagation of light. In this figure, the ray is traveling from left to right. Okay, and by the way, we shall try to follow the ray diagrams drawing incident rays always to incident from left to right. No problem? Okay. Then, next is a ray produced forward. See, here the broken line. Broken line means this is not the ray. Actually, the ray is up to here, then produced forward. You say, you are thinking, how do you get this? Suppose you have to keep a plain mirror, so the ray can't reach behind the mirror. So this is a ray produced forward. Likewise, what do you call? A ray produced backward. Okay? Next. A parallel beam of rays. A beam of rays converge at O. A beam of rays diverging from O. It's clear? Next, see the technical drawing. These diagrams are very commonly used. Check. What do you call? The beam of rays seems or appear to converge at O. Okay? The light beam seems or appears to converge at O. And another one is in this case, the beam of rays seems or appears to diverge from O. In place of converge, here it will be appears to diverge from O. Okay? All these things are clear? Now, as the proper topic, the reflection from curved surfaces. Dear students, actually curved surfaces are part of the hollow sphere. The example of hollow sphere you have the football, basketball, so a hollow sphere. Okay? Obviously, here is the center of the hollow sphere. Now the question is, of this football, if you take a small section, like see, as you are saying, the small section of the hollow sphere, as you see, so this side you see a circle and it is curved inward, and this is curving outward, bulging out. This is the curved surface which you see from outside. Okay? Now, if I take such a section and the inner surface is reflecting and this outer surface is non-reflecting, this is the inner surface is the reflecting surface and outer surface is non-reflecting. So this type of mirror is called a concave mirror. So how can you draw the diagram of a concave mirror? You see. So, and here is somewhere C, the center of curvature of the concave mirror. Okay? So this is concave mirror. Now, in the same way, if I take a section here and this outer surface is reflecting, then this is said to be a convex surface, or that is convex mirror, and the inner surface is non-reflecting. Silver polishing is there, so that. Okay, so this is what is a convex mirror. And here is the C, center of curvature. So let us come back to some important terms. First of all, C stands for center of curvature. So it is the center of the whole sphere of which the mirror is a part. It's okay. Then we hold like here and here. So what is the pole? Pole is the midpoint of the reflecting surface. Okay. Like as you see the concave mirror. So what is its pole? This dot is showing the pole of the concave mirror. Okay. What is the pole of the convex mirror? You see this is the convex mirror. What is the pole? This is the pole of the convex mirror. How do you draw the figure on the board? Again, a section of the convex mirror. You take a section like this and then face this. You check that. If I cut the mirror about in this way, then this section, this will be exactly the figure which you are showing this. Okay? Likewise, how can we see this figure? Concave mirror. If I take a section like this, if I take a section of the mirror in this way, so it's also known as the principal section of the mirror, and if I hold this, now think about that, the principal section appears like this. It's okay? Next, the principal axis. The line joining center of curvature and pole is called the principal axis. Here this is principal axis. Alright? Next we shall try to draw how the reflection takes place from the concave mirror. Okay. we have two characteristic points, one is center of curvature and one is pole. Okay? Next, number 1, an incident ray parallel to principal axis. Check. The incident ray parallel to principal axis. Then, how does it reflect? At first, try to draw a normal at the point of incidence. You try to draw a normal here. How can you draw the normal? You just draw a line joining the point and the center of curvature. So this is the normal. Obviously, this is angle of incidence side. Then draw the reflected ray, making angle equal to the angle of incidence with the normal. So like this, such that these two angles are equal. It is very simple. Law of reflection. Then put arrow sign showing the reflected ray. Okay. Now the question is a very important point is found here. The point where the parallel ray parallel to principal axis after reflection cut the point on the principal axis. Then this point actually is called the focus. F is here shown. Now I am going to draw the second important ray, but this is obtained just by reversing this ray. How? If I put the arrow sign reverse like this way, so this is incident ray, then this will be the reflected ray. So what is second? The incident ray falls on the mirror passing through focus. Then the reflected ray will be parallel to its principal axis. So I am drawing it separately. So we have 3 points instead of 2. We have now 3: center of curvature, pole, and focus. Later on, I am coming to the relation between PC and PF. Their relation we shall find later. So what is the second? The ray incidence through its focus. What will be the reflected ray? Parallel to principal axis. Okay, it's very simple. Then the third one. So we have 3 points. One is C, one is P, F, and another is B. What is the third? The ray incidence through center of curvature. What is the third ray? The ray incidence through center of curvature. As is suggested in this case, this line joining C and the curved surface on the mirror is a normal itself. So what is I in this case? 0. As angle of incidence is 0, so angle of reflection must be 0 by law of reflection, and therefore the ray traces the path. You understand? So, dear students, follow these 3 principal rays, incident rays and their corresponding reflected rays. They are very, very useful for drawing the ray diagrams. Okay. Now I am coming to the case of convex mirror. So draw the convex mirror, center of curvature and pole as suggested earlier. First one is the ray parallel to principal axis. You understand? Incident ray parallel to principal axis. Then we need to draw the reflected ray. How? Join the normal. How can you draw a normal? Join point of incidence to center of curvature. Okay, then this is I, angle of incidence. Now draw the reflected ray with the normal, make equal angles. So this will be the reflected ray, so that this angle is R and this angle is R, they are equal. Now check that the reflected ray seems to diverge from a point on the principal axis. In this case it is F. Diverge means here seem to come from, here single ray is there. If I draw another like this, then again so this is phi. Now draw the angle equal to this. So this is R, and now check this. So the reflected rays seem to diverge from a point on the principal axis, and that is called its principal focus. Okay? So are you understand? The incident ray parallel to the principal axis, after reflection, it seems to come from focus. Next, what will be the second diagram? Just reversing the arrow shape. So I am drawing this a concave mirror. Now you have 3 points: focus, center of curvature, pole. What is the second? The ray seems to pass through focus. You check the meaning. What is the meaning? It is incident ray seems to pass through F. Check this. Reverse the arrow sign. The incident ray seems to pass through focus. The reflected ray, reverse the arrow, it will be this. So if it is reversed, then it will be reversed. Okay? Then this will be the reflected ray. And the third one is the normal incidence. So you have C, here is A, here is B, and what is third? What is this? We can say that the incident ray seems to pass through its center of curvature. That means the ray falls on the mirror normal, that is here I equals 0. So the ray retraces its path, means reflects back along same path. Okay. Now if you try to define focus of concave mirror and focus of convex mirror, then know this. Definition of focus. Concave mirror. So you must draw this diagram. Take center of curvature midway between C and P, and now draw a parallel beam of rays parallel to principal axis, converge all of them on focus. Must not forget to put the arrow sign. In case of convex, how can you draw? For convex, you will a technique. How? Draw C, then midway between C and P is focus. Now draw parallel beam of rays. Let 1, 2. This is its shape also. You can draw 3 or like this. Then how to draw the reflected ray? Check the technical drawing. How can you draw? You join F and this by scale behind the mirror by local line and this. Put arrow. Okay? Oh, sorry. Okay? So the definition of focus. In case of concave mirror, how can we define the focus of concave mirror? A beam of rays parallel to principal axis after reflection from a concave mirror converges at a point on the principal axis. This is called the principal focus of concave mirror. Then how can we say for define the focus of convex mirror? Then you can check that when a parallel beam of rays parallel to principal axis after reflection from a convex mirror seem to diverge from a point behind the mirror, and that point is called the principal focus of the convex mirror. Okay? Next time we shall discuss about any difficulties. I will clarify all your points. Okay?